Okay, so today we're going to be looking at the origins of life. Now that we have discussed the characteristics of life and what actually makes something alive, let's talk about how life actually got here on Earth. So we go from the Big Bang and great, we have a universe now, and from that universe we have all this interstellar dust and other elements that are forming our sun and our planets, and we have galaxies and solar systems and all these beautiful things. And then the Earth forms about 4.6 billion years ago, and it's just this hot, molten ball of lava, essentially. So how do we go from this hot ball of molten lava to life as we know it today? Well, it's a journey. It's a long journey. It's been a 4.6 billion year journey. So let's talk about that journey today. The geyser represents conditions under which the first life forms may have evolved. So some early theories. Well, one of the earliest theories is the idea of spontaneous generation. And this hypothesizes that life arises from non-living things. So basically the idea that life can spring forward from a rock. We all know that rocks aren't living, or you should understand that rocks aren't living now. And spontaneous generation would say, well, life can come from a rock. So how was that theory actually disproved? Because we know that that's not true. We know that life can only come from other life forms. Life doesn't just magically spring forward from a rock. Thank goodness you have ants like popping out of your floor at you. One of the first scientists to disprove the theory was an Italian scientist by the last name of Redi. You should recognize his name from the reading that you did earlier in this year, How Scientists Work. So he was doing his experiments in the 1730s, and his hypothesis is that maggots arise from tiny, non-visible eggs laid on meat. Now, you have to understand that the concept of microscopes was still really, really new, so the idea of microscopic life was still being explored, still in the very early stages of exploration. So what Redi did in his scientific method, so the procedure for his experiment is he put meat into several jars, and he left half of those jars open to the air, and the other half he covered with a thin gauze to prevent flies from being able to get to the meat. So the results, after a few days, the meat in all of the jars had spoiled because it was exposed to air, but maggots were only found on the meat in jars that were not covered. So here we have his experiment, an example of his experiment. You see these 4 jars, and they all have meat in them, but 2 of them are covered and 2 of them are not. And the open jars had maggots covering them, and the jars that were covered had no maggots. So what this experiment proved is that the maggots weren't just magically appearing from the meat. They were actually hatching from these microscopic eggs that were laid by the flies when the flies landed on the meat. So this was evidence that was disproving the hypothesis of spontaneous generation. So experiments, other experiments that help to disprove some early theories. Louis Pasteur. Pasteur is the name from which the term pasteurization derives. So he was a French scientist working about 130 years after Redi's famous experiment. And he also was hypothesizing that life can't just spontaneously generate from non-living things. So he hypothesized that microorganisms do not arise from a nutrient broth, that bacteria is not going to just start growing in a nutrient broth. So let's talk about those. So in his procedure, in his experiment, what he did is he took nutrient broth and he placed it in a flask that had this long curved neck. And what this long curved neck did is it permitted air to enter, but it trapped dust and other airborne particles. So the air could get into the nutrient broth, but the dust and the airborne particles could not, because they were getting trapped in sort of the elbow of the long curved neck. And then he boiled the flask thoroughly to kill any of the microorganisms that were already in the nutrients. And he did not seal the flask. Now, Pasteur was a very patient man, so he waited an entire year before gathering his results. And this is what he found. After a year, no microorganisms were found in his broth. Pretty incredible. So you can see the long neck, and you can see the steps of his experiment. He took this nutrient broth, he put it in the flask with the long neck. He heated it. After a year, there were still no microorganisms growing on it because they were getting trapped in the elbow. So what Pasteur then did is he removed the long neck, which permitted dust and other particles to enter. And within just one day, the flask contained microorganisms. So what this clearly demonstrated is that these microorganisms weren't just spontaneously generating on the broth. They were actually coming into the broth from the air, so that there were these microorganisms, bacteria and whatnot, floating around in the air and landing on the broth. And when they landed on the broth, they had the nutrients they need to then grow and develop. And this is actually true. This is why if you leave food out on your counter, it will start growing bacteria. Versus putting it in the refrigerator covered, it takes a lot longer for bacteria to start to grow. So anytime you take leftovers out of the fridge and you take the lid off and then you put the lid back on and you put it back in the refrigerator, you have actually exposed it to some microorganisms that are living in the air. And those microorganisms will eventually begin to grow and reproduce if you don't eat the food fast enough. Okay, so this disproves the idea of spontaneous generation. Basically, Redi and Pasteur's experiments demonstrated that life can only arise from other life. Life cannot arise from non-living organisms. That's great. That's wonderful. So how in the world did life get here? If there wasn't life here in the first place, how did it get here? Well, that's what two other scientists set out to try to find out. So some current theories on how life originally came to evolve and exist on Earth. And remember, in this class, we are studying the theories for which there is the most evidence. All right, so in order to have life, we need complex molecules. We need something more than just hydrogen, helium, and atoms. Life is so much more than just simple elements. We need complex molecules. And what Miller and Urey were setting out to do is to try to understand how complex molecules came to evolve in early Earth and how those complex molecules then could lead to the evolution of life on our planet. Some of the elements that they were using were a mixture of hydrogen, methane, ammonia, and water, because those were present in Earth's early atmosphere. So they took this mixture of hydrogen, methane, ammonia, and water, and they added to it an electric spark, because that electric spark was representing lightning that would have been present in Earth's early atmosphere. And what they got out of this experiment was extraordinary. Within a few days, they basically had a soup of molecules that had formed. And one of the molecules that formed was amino acids. Now, this is very, very important because amino acids are the building blocks for proteins. Everything in your body is made out of proteins. There's only 11 amino acids, but those 11 amino acids make up over 200,000 different types of proteins in your body. So there's protein for your hair, and protein for your skin, and protein for your organs, and this is why it's so important to have an adequate amount of protein in your diet, because your body needs to take that protein and break it down so it can make its own protein. And when it's breaking down proteins, it's breaking it down into amino acids. So amino acids were essential for the evolution of life on Earth. And amino acids are what Miller and Urey were able to create in their experiment. Reactions similar to Miller and Urey's experiment occur today near volcanic vents at the bottom of the sea. So it's more evidence supporting Miller and Urey's experiment. All right, so the formation of complex molecules such as amino acids, which are the building blocks for proteins. Collections of these molecules, they tend to gather together into tiny round droplets known as coacervates. Coacervates are basically proteinoid microspheres. So they're basically little spheres that are precursors to what eventually will become proteins. So the molecules that Miller and Urey were able to create in their experiment have a tendency to gather together into these precursors to proteins. In a laboratory, these coacervates have been shown to grow and divide, which is one of the characteristics of life. So coacervates themselves are not living, but their existence suggests ways in which the first cells may have evolved. So there may have been this sort of primordial